Hello friends, my name is Ramasu. Today we shall discuss about topic the naive Bayes. Friend, today's topic is very interesting, especially if you have interest in machine learning or artificial intelligence and you want to learn about it. So let's just start, friend. First of all, I would request to please subscribe to my YouTube channel and click on the bell option as well, so that my new videos can reach to you, and also you can follow me on the Facebook page as well. So friend, today we shall discuss it in detail that what is naive Bayes. And naive Bayes algorithm is a supervised learning algorithm which is based on Bayes theorem and used for solving classification problem. It is mainly used in text classification that includes a high dimensional training dataset. Naïve Bayes Classifier is one of the simple and most effective classification algorithm which helps in building the fast machine learning models that can make quick predictions. It is a probabilistic classifier, which means it predicts on the basis of probability of an object. Some popular examples of naive Bayes algorithm are spam filtration, sentimental analysis, and classifying articles as well. The naive Bayes algorithm is comprised of two words, naive and Bayes, which can be described as naive. Basically, naive, it is called naive because it assumes that the occurrence of a certain feature is independent of the occurrence of other feature, such as if the fruit is identified on the basis of color, shape, and taste, then red, spherical, and sweet fruit is recognized as an apple. Hence, each feature individual contributes to identify that it is an apple without depending on other. Bayes, it is called Bayes because it depends on the principle of Bayes theorem. Bayes theorem is also known as Bayes rule or Bayes law, which is used to determine the probability of a hypothesis with prior knowledge. It depends on the conditional probability. The formula of Bayes theorem is that. Okay, this is the formula of naive Bayes theorem, where basically a friend PA B is basically is a posterior probability of a hypothesis A on the observed event B. Next is the PB slash A. This is likelihood probability of the evidence given that the probability of a hypothesis is true. Then PA, this is a prior probability of hypothesis before observing the evidence. PB is marginal probability, that means probability of evidence. Okay, now friend, working on the native Bayes means that we discuss it in detail, that for example classified can be understood with the help of the some examples. Suppose we have a data set of weather conditions and corresponding target variable play. So using this data set, we need to decide that whether we should play or not on a particular day according to the weather conditions. So to solve the problem, we need to follow these steps. First, convert the given data set into frequency tables. Generate likelihood table by finding the probabilities of given features. Then use Bayes theorem to calculate the posterior probability. Then if the weather is sunny, then the player should play or not. This is the basic problem or question. Now the data set, friend, this is the data set which is basically we used for calculation. Okay, this is the data set. Okay, then next is the frequency. This is the frequency table for the weather condition, which is calculated from the data set. Okay, then next is the likelihood. Likelihood means that friend, we have likelihood table from weather conditions. This is the likelihood. Now applying the Bayes theorem. Bayes theorem we applied through, like for example, P yes sunny, so we calculate through the formula, and the value of P yes sunny is basically 0.60. after the calculation. Okay, then P no sunny. Okay, the answer for is 0.41. Okay, so for yes 0.60 and for no 0.41 after the calculation. This is the calculation here. So as we can see from the calculation that P yes sunny is greater than P no sunny. Okay, so that means on a sunny day player can play the game. Okay friend, this is the observation, this is the calculation, or you can say application of the Bayes theorem. I hope you like this video. If you like it, please share it with your friends and colleagues. If you have still any question, you can ask me in the comment section. I would love to answer your query. So thanks a lot for watching the video. Thank you friends.